This is an orthokeratology case that started out as a hyperopic case. In this video, I'm going to do a demonstration for molding cylinder, and we're going to kind of ignore the plus 50 and just try to get rid of minus 1 cil, a diopter of corneal cylinder. This is a pretty low overall prescription. The topography does have some unique features to it, so I would definitely proceed with caution, make sure the patient has the correct expectations, and hopefully we can get an overall successful case. So I'm going to stick with the 11.0 diameter that you have. I'm assuming that's going to be good for this particular cornea. I don't have the baseline topographies, so I'm just going to stay with 11.0. I'm going to go and just create a standard corneal reshaping or ortho-K for myopia lens. 5.8 and 6.4, I'm actually going to increase this a little bit to very commonly used 6.2, 6.8. We're going to maintain your overall diameter of 11 millimeters. And we can reduce the power. This is a pretty low prescription. I'm going to leave it in G-Sim mode and just hit continue. Okay, so now we have a lens built, and you can see that because of the very low prescription, Wave is not even categorizing this as an ortho-K lens. And so one good thing about that is you can probably order this lens warranted, and in case you needed to make an exchange, you could take advantage of Wave's warranty policy. So we have a lens where there's very low demand in the horizontal meridian, which is expected. It's pretty close to plano. Vertically, however, we do have more of that reverse curve generated. And then in order to create an oval zone, what we want to do is in the superior and inferior meridians, we want to shorten the OZ and increase the demand a little bit. So I'm going to first of all decrease the overall demand. Since the sphere power is pretty close to plano, a demand with a power of 1.25 is probably a little bit more than we need. I'm going to reduce this and probably get it just under our diopter. And then our target in the vertical meridian will be a diopter more than that to take care of the cylinder. So our target in the vertical meridian will be approximately plus 1.97. And the way to do that is I'm going to go to 50% mode. Currently our OZ and IC are set at 6.2 and 6.8. What I'm going to do is reduce that so that we're at 5.6 and 6.2. So I'm going to reduce this to 5.6 and reduce this one to 6.2. Because we're in G-Sim mode and 50%, the same thing automatically occurred in the inferior meridian. The next thing I'm going to do is add in that extra diopter of demand. So I'm just going to click up here until we're right around 2 diopters. And that's pretty close. Again, because we're 50% mode in G-Sim, the software did duplicate that in the inferior meridian. And then the last thing I might do is perhaps in 100% mode, just try to get this lens to line up a little bit better in the periphery. And bear down. You do see a little bit of clearance superiorly and inferiorly, and I'm not sure if that's a component of the topography. If this irregularity in the topography is just from tear film or perhaps eyelid position, then it's okay to have a little bit of clearance. If this appearance in the topography is true, the cornea does have superior ectasia to it, then you just have to be careful. It may not be a case that you want to mold at all. But I would not go to a freeform lens from the outset. I would go to a G-Sim first and see how that fits on the eye. And see what kind of results you're going. You can always troubleshoot from there. So here we have a lens where superiorly the zone is smaller than in the horizontal meridian. There's very little demand in the lens horizontally. Most of the molding is going to take place in the vertical meridian, and the idea is to reduce as much of this diopter cylinder as we can. So this would be a starting point for a case. Again, this would not be a case that I would normally take on, but at least for academic and discussion purposes, I hope this video helps, and I wish you the best luck with the patient.